So those of you that just came in, happy Wednesday. Happy Wednesday. All right, so let's go over these problems. So the question is, or this problem, the question is, are these triangles similar? And if they are, write a similarity statement. So let's see. If we look here, the only way we know how to show if they're similar is AA. Haven't taught you SSS similarity, haven't taught you SAS similarity. I've only taught you AA. So that's the only way we know. So if we look here, we see 68 degrees for A and 68 degrees for F. That's one pair, right? And in order for it to be similar, we need two pairs. And if we look here, this is 63, but that's 54. So I put different colors because they're not the same. Okay, excuse me. Sorry about that. Had to sneeze. Okay, so we give up now, right? We say, nope, we only have one pair. We're done, right? Because we don't have two pairs, because those are different, we're finished, aren't we? Or does somebody have an idea of something? A and F are both 68. Very good. That's why I painted them both pink. So yes, they're the same. D and G are different. B and E, we don't know the measures, so we can't say B and E. And then someone said B and G. Why B and G? We don't know what B is. Can we find out what B is? Is there a way to find out what B is? How? How can we find out what angle B is or angle E? How can we figure either of those out? Does anyone know? How? Tell me how. I don't have that sound effect. Somebody tell me. Because yes, you're right. There is a way to find out the measure of angle B and the measure of angle E. I just want you to tell me how. Because it's boring if I tell you how. I'm the teacher. I've been doing this for forever. Come on, guys. How? How do we do that? How do we find angle B, the measure of angle B, or the measure of angle E? Add, there you go. Very good. Add the other measure, because every triangle, the angles add up to 180. So the 68, so for this triangle, 68 degrees plus 54 degrees plus the measure of angle B equals 180, right? If I add these three, they should equal 180. So 68 and 54, that's 2, 12, 11. So that's 122 plus the measure of angle B equals 180. So if I subtract 122 from both sides, I will get the measure of angle B is 58. Is it 58? What is it? 12. It is 58. And so this is 58 degrees. And angle E, if I do 63 degrees plus 68 degrees plus the measure of angle E, that should equal 180. So 128, 131 plus the measure of angle E equals 180. So if I subtract 131 from both sides, the measure of angle E equals 49. So if I look here, this is 49 degrees. This is 58 degrees. And we look and nothing else is equal. Nothing else is equal. So we say, no, these are not similar. So nothing's equal. So at least we tried, right? When you first see that we only have one set of angles, don't give up. Check out the other angle. You can, if you know two angles of a triangle, you can always figure out the third. So that's what I would do. I would always figure out all three to see if we had any pairs, and we don't. We don't. So the answer is no, sadly. Okay. So again, here are some things we talked about yesterday. We talked about parallel lines, right? Parallel lines giving us angles that are equal. Vertical angles giving us angles that are equal. in order for us to prove triangles are similar using AA. Okay? So that's one way. The second way, so let's go back to the first page. The second way to find triangles similar is SSS Similarity. Oh, wait. Somebody have a question about this one, the warm-up, before we move on? Somebody said, why are they not? Okay, so someone asked in the chat, Mister, hold on, give me a second. Okay, so that's fair. Mister, you're going too fast. Thank you. Okay, see? Exactly. Thank you for letting me know. Thank you for letting me know. When you look at your diagram and you see that you only have one set of angles, like we did here, we only had this and this, A and F were the same, but we didn't have another set. Always check to make sure that third angle doesn't match with the one that we have. They didn't here, so we said no, but always check. And how do you check? Well, if you know two angles of a triangle, you can get the third because they all add up to 180. Right? And that's how you get the third angle. They all add up to 180. And that's how you get the third angle. Okay, good question. So how do we know? We got the third angle by saying, what is left over to make it 180, to add all these three to get 180. And then we see if anything matches. We did that, nothing matched. We only had one pair. And this kind of answers the question yesterday, Mister, what if we only have one pair? Can we say they're similar? No, it has to be two pairs or two sets of congruent angles. Good question. And I'll leave this here for 20 seconds because some of you are like, Mister, you're going too fast. Thank you for letting me know. Good job. See, you guys are getting better. Thank you. I appreciate that. See, if you say something in the chat, I don't say who said it, and it doesn't matter who said it. It's helpful. Yeah, if I'm going too fast, let me know. If you don't understand something, let me know. If you need me to repeat something, let me know. If something's too blurry, so somebody was telling me yesterday that it was very blurry. It was getting blurry in and out. That was my fourth period. I don't know if that happened here, but you need to tell me that too so I can zoom in. The recordings are a lot better, so I don't know if you've gone to the YouTube or clicked on the links of the videos after I put them up, but they are much clearer. You can all the way up to 4K, so you can see things a lot clearer. So let's say you take some notes. You're like, I didn't see what that was, and if I didn't ask Mister, you can go to the video, go to the spot where you need to, and then pause it. All right, so now let's talk about SSS Similarity. This is the second way. So how do we do this? So if all corresponding sides are proportional, then the triangles are similar. So that means we need to make ratios of the corresponding. What does corresponding mean? Anybody? What does corresponding mean? It's just a fancy way of saying right? When we have two triangles, we want to match up. We want to match up the sides. So the corresponding just means the matching sides. Okay, so if all matching sides are proportional, so proportional, what does proportional mean? It means the ratios are equal. Right? That's what a proportion is, two fractions that are equal to each other. So when I make a fraction of corresponding sides, they all should simplify to the same fraction. Okay, so let's see. Let's look at this. So in this case, we have to try and figure out what the matching sides are. So we're going to have to eyeball this. So I think this side matches with this side. It looks like this side matches with this side. So you're going to have to do some guessing work because it doesn't tell you. And I think this side matches with this side. Okay, so now now I decide I'm going to go from small to large. Okay, so I'm going to go from small to large. So let's do this ratio first. Does that equal that? So we're looking at the matching sides now. So I'm going to look at the orange one first. No, I'm sorry. What am I doing? We don't know. We're just going to, okay, I'm sorry. We're just going to make ratios and see if they all are the same. So the first ratio I'm going to make is the orange ratio. Let's make the orange ratio. So what's the orange ratio? 3/6. And what does that simplify to? What does 3 over 6 simplify to? That's a simple one. Come on, people. I need you to participate. Come on, wake up, wake up. Thank you, thank you. 1 over 2. So the orange one, the orange sides are 1 over 2. All right, let's try the pink ones. Let's try the pink sides now. The pink sides are, let's go small to large, 5 over 10. And what does that equal to? That also equals to 1 over 2. Wait, where did you get? Someone's asking some question in the chat. Where did you get 1/2? 3/6. 3/6. This is simplifying fractions, right? Divide by 3, divide by 3. Right? If there's 6, come on. If there are 6 slices in a pizza and I eat 3 of them, I ate half the pizza. 3 out of 6, right? Okay, so the pink one is 1/2. Now let's try the green one. Let's try the green one. Green one is 4. Oops. 4 over 8. And if I simplify that, 4 over 8 is also 1 over 2. And so if you look here, do all of these equal each other? Yes. So we can say yes, happy face, because of SSS similarity. And that's it. That's it. All you got to do is look at each ratio. And if all the ratios simplify to the same rate, remember, this is your rate. These are your ratios. These are the rates it's growing. So that's saying that this triangle is half the size of this triangle. Or this triangle is double the size of this triangle. And all we got to do is make a fraction of the matching sides. 3 over 6, 4 over 8, 5 over 10. And they all are 1/2. They all have the same ratio. That means they grow or shrink at the same rate. So yes. Remember, all three. If only 2 of them are the same, no, it has to be all 3. Make sense? Good, good. Any questions? If it doesn't make sense to you, please let me know. All right, let me give you a second to copy this. Oh, the similarity statement. Thank you. Thank you. So now we know the matching sides, right? So let's say, we're going to have triangle blank, blank, blank is similar to triangle blank, blank, blank. Well, let's start here in the corner where green meets orange. Green meets orange. So you're going to have to do the similarity statement by where the colors meet, right? Or you can do different colors and say, okay, but let's do this. So green meets orange. So P and S. So P and S. And then where do orange and pink meet? Orange and pink meet at Q. Orange and pink meet at Q. So Q and T. Q and T. And then pink and green meet at R. Pink and green meet at U. So R on the small one and U on the big one. And there you go. Okay. Thank you. Thank you. Someone in the chat said, Mr. Don't forget the similarity statement. Thank you. That is in the instructions. And then how do we write our similarity statement? Just see which angles match. And the way I do that is I just look at orange and pink meet at P. I'm sorry, orange and green meet at P. Orange and green meet at S. So P and S go first. I'm just going to put those first because they match. Orange and pink meet at Q. Orange and pink meet at T. So Q and T match. And then green and pink meet at R. Green and pink meet at U. So R and U match. That's how I figure out what matches with what. Does that make sense? Using my colors again. Colors are so much easier to match than trying to figure out what letters match with it. I've seen that over the years. When I first started teaching, I would not use any colors. And kids would get confused. Wait, does P go with R? No, does P go with T? Wait, I'm confused, mister. As soon as I started doing the colors, oh, it makes sense. Orange and green, orange and green. Orange and pink, orange and pink. Pink and green, pink and green. Those are what match. And I'm done. All right, let's see if you get this. You try this one. You try this one. All right, time is up. Time is up. So I had a great question during this time. Somebody asked, Mister, in the previous problem, how did you know to put the 5 on the top and the 10 on the bottom, or the 3 on the top and the 6 on the bottom? So I've always told you that the order of the ratio is determined by the question. But if you look at the question here, it doesn't tell you anything. It doesn't tell you which one goes first or second. So you get to choose. And in this problem, I chose to put small over large. So you got to make that choice. How are you going to make your ratios? Doesn't matter as long as you keep it consistent. Okay, so you get to choose. What's going on here? You get to choose, and I chose small over large. So make sure whatever you choose, you do the same thing for all your ratios. Because if you do the opposite on one of them, you're going to get different answers. So right here, I'm going to choose, well, this is the large one. And this is the small one. I'm going to choose large over small. So I'm choosing my ratios to be large over small. That's just my choice. Okay. You could choose small over large. You'll get the same thing. It's just upside down, right? You'll get the same thing, but upside down if you did the other thing. So if you see here, I matched up the sides by doing colors. I think CD and FG match. I think DE and GH match. And I think CE and FH match. Okay, so I'm going to make my orange ratio, my green ratio, and my pink ratio. So let's do that. So my orange ratio, let's go orange since it's over here. 30 on the top, 24 on the bottom. Then my green ratio is 35 on the top, 28 on the bottom. And then my pink ratio is 32 on the top, 25 on the bottom. Okay, so let's simplify. 30 over 24. Well, I can divide by 6, right? Divide by 6, divide by 6. And so I get 5 over 4 for my orange. So for green, 35 over 28. Well, I can divide by 7, and I get 5 over 4. Ooh. And then over here, 32 and 25. Can I divide those by anything? 32 is 8 times 4. 25 is 5 times 5. No, this is it. So guess what? Guess what? I had 2 of them. I had 1, 2, but not the third one. And if you're thinking, okay, mister, you said if they don't work to try to match up other sides. Well, here's how I think I can match up other sides. If I match up 35 with anything else, can I divide anything else by 7? And I'm looking here, and it doesn't look like I can, right? It doesn't look like I can divide anything else by 7. And if I look here, I would have to divide this by 5. I can only divide that by 5, right? So is there anything else here I can divide by 5? Yeah, I could divide this by 5, but nothing else. So it doesn't look like, because of this, because I divided by 7 for 35, but I can divide by 5. So if I do 35 over 25, if I switch these and then I do 32 over 28, let's see, 35, if I divide that by 5, I get 5 over 7. Then I divide this by 4. Divide this by 4, I get 8 over 7. No, nothing's working out. Well, and the 30, right? I could do the 30. But I'm just going to let you know, if you are mixing and matching this, you're not going to get it. You're not going to get the same ratios. We were very close. These matchups were the closest. We had 2 of them the same. Third one wasn't. So the answer is, sadly, no. No. Right, so yeah, we could have do the 30. We also could divide 5 by the 30. But yeah, anything you mix and match wouldn't have given us what we wanted. But we came close. We came close with these matchups. Almost. So remember I told you all three ratios have to be equal, and not 2, all 3, in order for the triangles to be similar. All right, you want to try another one? Let's go down to the practice problems. And let's try number 8. It's a triangle inside a triangle. Okay, so I would draw the 2 separate triangles if I were you. Okay, so I'll give you 7 minutes again. Actually, I'll give you 4 minutes. I'm sorry, 4 minutes to try this. All right, time is up. Time is up. So if you noticed, I drew the 2 separate triangles. Always want to do that. Okay, I drew the small one, so I drew this one right here. I drew it right there. And then I drew the large one over here. So the small one's easy. So WVX, WVX. And we have 15, 30, and 20. So I put 15, 30, and 20. The large one, WYU, I have 42 down here. But what's the length of this side? Some of you are putting 6, but the length of this side is both of these. 15 plus 6. It's this plus this make the whole side. Okay, so what would that be? Oh, I have someone. What would that be?
21.
Thank you, thank you. That is 21. That is 21. And then we have this and this, 20 and 8, right? We got to add both of these. It's not just 8. 8 is just this part. We need the whole side. So it's 20 plus 8, which is?
21.
No, it's not 21. It's 28. It's 28. Okay. So now let's mark the matching side. So I'm going to say this side matches with this side because these were two were together on the same side. I'm going to say this side matches with this side. And this side matches with this side. And I'm going to say my ratios are going to be small over large. That's my choice. Okay, so let's do the pink ratio. Let's do the green ratio. And let's do the orange ratio. All right, pink ratio is, I'm doing small to large, 20 to 28. The green one is 30 to 42. And the orange one is 15 to
21.
Yes, thank you. 15 to 21. Okay, so let's simplify each one of these. 20 and 28. What can I divide 20 and 28 by? You can divide it by 2, mister. Yes, we can divide it by 2. Is there a bigger number I can divide it by? 4. How about 4? All right, let's try 4. Divided by 4, divided by 4. So that's 5 over 7. Okay. What about 30 over 42? You can also divide those by 2. Yes, we can. Is there a bigger number? Oh, we can divide those by 6. Ooh, good job. Divided by 6, divided by 6 gives me 5 over 7. Ooh, we're almost there, guys. We have 2. We have 2. All right, what can we divide 15 and 21 by? 3. We can do 3. Very good. Divide by 3, divide by 3. So I get 5 over 7. Woohoo! We got it. We got it. 5/7, 5/7, 5/7. So that's saying that the small triangle is 5/7 the size of the big triangle. So now let's write a similarity statement. Triangle blank, blank, blank is similar to triangle blank, blank, blank. Actually, is there a better place to do this? It's getting a little crowded, isn't it? Let's do it right here. Triangle blank, blank, blank is similar to triangle blank, blank, blank. So let's match up the first. So I'm going to do pink green right here. Pink green is V. Pink green is U. So V matches with U. So I'm going to put those first. And then pink orange is W. Pink orange is W. So both of them have W second. We'll put that second. Now, it doesn't matter which one you put first, second, or third as long as they're matching, as long as the order is matching. It doesn't matter which one you put first, second, or third. I just chose pink green to be first. Doesn't matter which one's first, second, or third, as long as when you put them in order, they are matching. Okay, and then the last one is orange green is X, orange green is Y. So we put X here and Y here. And there you go. And I chose to put the small one first and the large one second. That was my choice. Mister, yeah, I did W first. Okay, so if you did W first, you would have had like WXV. That's fine, as long as the next triangle has the match. What matches with W? W. What matches with X? Y. What matches with V? U. Okay, as long as everything is matching, the W and the W match, the X and the X are second, they match, and the V and the U are third, they match. Right? The V and the U match, W and W match, X and Y match. Okay? All right, so that's SSS similarity. So here's what we're going to have to do. Tomorrow we're going to have to go over SAS similarity. It should be a lot quicker because it kind of combines AA similarity and SSS similarity. So now we know two. If we look up here, we know two of these. We know two ways to prove that triangles are similar. Tomorrow we're going to learn the third, and then we're going to do the classwork. We're going to do as much as we can. I know we're not going to have a full class to do it, so we're going to do as much as we can. And please continue to do some of the homework problems tonight. Remember, there's only 2 assignments this week. So if you want to maintain that A, you need to do those 2 assignments, the classwork, which we're starting tomorrow, and then the homework, which you should have done maybe a problem or 2 yesterday. Do a couple of problems tonight, so that way tomorrow it's not as much. Does that make sense? All right, everyone, that's it for today. If you have any questions, you can let me know now, or you can send it to me on Schoology, or you can ask tomorrow when we get back. But tomorrow is our Friday, so we'll be hearing the Friday song on a Thursday because tomorrow's the last day of the week. And I want everyone to take care and have a great day.